believe it or not, you guys have worked with medians before, but you worked with them. Yeah, you have. You worked with them before, but you worked with them with numbers. For example, if I say numbers 1, 2, 4, 9, 12, 15, and 21. When you guys had a sequence of numbers at some point in time, you guys had to find what were called mean, median, and mode. Remember that? What did the mean stand for? Remember?
Average.
The average, good. So the mean was the average. So in order to find an average, you would add them all up and divide by the number of things you had. The median was the what? The middle number. The mode was what? Yeah, the most. The one that was mostly used. Here I had no mode because everything was used once. But here I do have a median. What would my median be? 9. The reason why we would say that 9 in this case is my median is because there's 3 here, there's 3 there. Now, if you think of that in terms of a segment, what's the median of a median? What's the median of a segment? It's midpoint, exactly. The median of a segment is nothing more than a midpoint. What's up, man? How are you? Yeah, the median of a segment is nothing more than just a midpoint. Okay? So a median for our purposes, the median of a triangle is the segment from vertex to a midpoint. Okay? It's a segment from a vertex to a midpoint. Now, we had earlier in this chapter a whole bunch of things that connected midpoints. When we connected midpoints earlier in this chapter, we called those what? When you had midpoints in a triangle earlier in this chapter, we connected them to segments. What were those called? Mid-segments. So mid-segments were the segments that connected midpoints, but they were going from midpoint to midpoint, not from a vertex. Okay? So you still have midpoints, you still have these relationships like this where all these segments want to go right. Because the mid-segment is equal to half of this alignment side. Now, what happens that's a little bit different with medians on the other hand, is that they look ever so slightly different. They are nothing more than taking a triangle, kind of guesstimating where your midpoints are, and you're just drawing from the opposite vertex to it. Oops. It's close enough. Okay. And notice they still meet at one spot. Excuse me. So we have what are called medians. Medians are segments from vertex to midpoint. And obviously you have 3 of them. If you want to remember that when you're dealing with median, the median is always going to be vertex to the midpoint opposite. It's always going to be the one across from you. You never have to worry about them going to the sides next to each other because those are the sides that make up the angle. Those are the sides that make up the vertex. You don't have to worry about it. It's always just be the one straight across from you. So, medians? Maybe. Maybe not. I'll get there. And actually, the next one. The medians. What was it called when all 3 medians run into each other? Yeah,
the three medians are always going to be what we call concurrent, which means they run into each other. They have this point, what's called a point of concurrency, which means it's going to have a weird name. So when you have medians, again, they intersect. It's close enough. Notice how the diagrams, remember how we had the perpendicular bisectors? They also ran into what would basically want to be in midpoints, but the difference between those and a median, the medians aren't necessarily going to be right angles. They possibly could be, but they don't necessarily have to be. Whereas the other ones, they're always going to be perpendicular and bisector. Okay? That's kind of how you tell the difference there. This point is a weird name. Where they all run into each other, it's called a centroid. Okay. The point at which the three of these guys run into each other, this point of concurrency, it's called the centroid. And what's weird about that value is that if you look at it in terms of segments, if you will. If you look at it in terms of a segment, where does a median start? And where does it end? If you think about it, just real boringly, a median would start at a vertex, and it ends where? It ends on the side across, right? Along the way, it runs into its centroid. So if I think of it, isn't that median made up of two smaller segments? Are you okay with that? Now, let me try this. So the median is made up of the segment from vertex to centroid plus centroid to side. And what I'm doing here is I'm abbreviating the word centroid with cent, C-E-N-T. Is that okay with that? Did you get over it though? That's all I can ask. It's not technically the center. Okay. It's not technically the center. And this is where it gets a little bit weird. You have this whole segment here. That whole segment goes through the centroid. And the weirdness of it comes out of this. 2/3 of the whole thing is that segment from the vertex to the centroid, which leaves 1/3 of it for the other spot. Okay. It looks, bless you, it looks really, really weird. But if you think about 2/3 and 1/3, 2/3 is basically doubling 1/3, isn't it? 1/3 is then half of 2/3, right? So if you really start thinking about it, even though you see these weird fractions, yes, ma'am. Yes, ma'am. So if you think about this, just for rough numbers, if I say that this much is 10, what would the other side? 5. So even though it looks really weird, this whole idea of 2/3, 1/3, if 2/3 of something is 10, half of that has to be 5. And the same thing goes for if one portion of it is 7, the other side has to be 14. Okay, see where I'm going with that? It's, even though you're starting to see that there's this weird, yes, sir. Yeah. And I'm going to rewrite all that out here in a second for you. I just wanted to show you that don't worry about seeing this fractional value of 2/3, 1/3. That's usually where I wasn't coughing the last hour and a half because I wasn't coughing. No thinking. I'm at. And what's weird for most people to just grasp is that 2/3 is just doubling 1/3. 1/3 is just half of 2/3. It's not that you have to worry about the whole fractional amount. Sometimes you will have to worry about the fractional amount, and that's when we get to the algebra. But it's super easy to work with. You're 9 times out of 10 you get a decent number. It's not that it's going to be a blow. Plus you have, I don't touch your calculator, but you have the calculator for a basic. And that has a fraction bar behind it. All right. So back to the idea where I was starting here. Oops, wrong button. When you have this idea of a centroid. The centroid, vertex, bless you, the centroid is 2/3 the whole. Centroid to side is 1/3 the whole. And that's kind of what I want you guys to think of. Vertex to centroid is 2/3 the whole. Centroid to side is 1/3 the whole. And if you want to get fancy with it, centroid to side is half vertex to centroid. I know there's a lot of little relationships that get thrown into that, but if we have a couple of them written down, we start to see a couple of numbers. As long as you can identify what part you're working with, it's super easy. It really, really is. Again, if I'm looking at my diagram here, and this guy is my centroid, if I say this much is 12, what's the other side? 24. Okay. If I say that this whole thing, if this whole thing here is 30, if the whole thing is 30, what's the small chunk? 10. It's 1/3 of 30. Again, it's going to be a number that's easily divisible. Okay, 30 divided by 3 is how much? 10. Double 10, what do you get? 20. What's 10 plus 20? 30. So that means it breaks down to 10 and 20. All right. See how quick that can be? Yes, ma'am. Yeah, because that's what they do. The medians are segments that go from vertex to midpoints. There'll always be vertex to midpoints. So it seems crazy to think as you go through this, but it's when you start mathing it, mathing isn't really all that bad. What's up? Oh, we got Marissa. Do I where?
You're 21.
24. Haven't you figured out my chicken scratch yet? Oh, and you're welcome for your glasses yesterday. Yes, because you left them in my classroom. Is that better? Sorry. There. Tiny, right? Tiny. So, as you get into these types of problems, ladies and gentlemen, it's can you identify which part are you working? Do you have what they call that the circumcenter, the in-center, or the central? Right. There's just some, like we said, some weird vocabulary. The math isn't tough, it's just the vocabulary that's up. Picture. Don't draw this all out. Let's see if we can figure this out on our own. If A is a centroid, and XA is 8, if A is a centroid, and XA is 8, what's the entire segment going to have to be? 12. Be 12. Because remember, the centroid cuts it into 2/3 and 1/3. If that segment from the vertex to the centroid is 8, that means the other side is the centroid to side, which means it's half of 8. Yeah. Half of 8 is 4. 4 plus 8 is therefore 12. That's how it works. So you have the vertex to centroid equals 2/3 the whole thing. So there's a couple of ways you can do that. If I know this much is 8, XB is that whole thing, isn't it? Do you guys remember how you undo multiplying by a fraction? Multiply by its reciprocal. Okay. So what's the reciprocal of 2/3? 3/2. So I would multiply both sides by 3/2. What's 8 divided by 2? 4 times 3 is? So you can do it the algebraic way and write it out using the straight formula stuff if you'd like. Or if you think about it when you're working with numbers that are relatively easy, most of these will. Excuse me. If you know that 8 is the one chunk, cut the other chunk in half, the other part has to be half of it. Okay? And just work your way out of that. You should not see a ton of really craziness here. What's that? I'm sorry, I can stop because I know. Let's talk about altitudes. Altitudes are another thing you guys have all dealt with. It's a long-winded definition. I don't like it. How many times have your parents told you to stand up straight? There you go. Well, they should tell you more often. So your parents tell you to stand up straight because that's as tall as you're going to be. You stand up nice and straight, right? Not like when you guys walk around with your slouch over your phones for walking down the hallways. Yeah. Couple things you need to start investing in now, guys. Back braces. You think and hearing aids. Seriously, the amount of time if you literally unplug yourself for a second as you're walking down a hallway in a high school and just watch kids walking by, 80% of them have earbuds in there, and of that 80%, probably about half of them have it so loud that you can hear them, and the other 90% of all students are walking around like this on their phone, doing all that as well. So your posture is going to crap. Your hearing is going all to pieces. Yes, ma'am.
In our school, people don't wear headphones.
Yeah, I know that's kind of annoying too, but you get the idea what I'm getting at. So, but you see what I'm saying though is, you guys, if you were smart, take $20, and put and start investing in like hearing aids and things. I'll be a silent partner in your investment, right? So the altitudes are a little bit different. I'm getting there. An altitude is a segment, from a vertex that's perpendicular to the other side. An altitude is a segment that's perpendicular to the other side. You guys have all learned that segment before as the height of a triangle. When you guys have dealt with finding the areas of triangles in the past, you guys had to deal with the height, and that height was where it was perpendicular from a vertex to a side. Well, technically that segment is called an altitude. So you've all seen this before, you just didn't know it was called an altitude. Okay? So anytime you draw a segment from a vertex so that it is perpendicular to the side across from it, it's called an altitude. And lo and behold, looky, well, if I drew that nicer. Yeah, just make it bigger dot, right? Lo and behold, those three values run into each other again. So the altitude Yeah, thanks for seeing that too. I was wondering what I was doing. The altitude is going to be the segment from excuse me, vertex to side that is perpendicular. It doesn't bisect the side, it doesn't do any of that, it's just perpendicular to that side. Now, I drew this first diagram as a real generic acute triangle. What's weird with the altitudes is that altitudes can meet inside the triangle, they can meet outside a triangle, or they can meet on a triangle, depending upon the type of triangle that you have. And again, when you guys found areas of triangles before by doing 1/2 base times height, you've all seen this. For example, can I go to a clean one here real quick to show you a picture? Waiting. Oh, I was just going to do another one on the smartboard real quick. He's going to say I have to sit in the water. But my drawing's so beautiful. So you guys, when you guys use kids, no, don't draw. Just by looking at that, if I wanted to classify that triangle via its angles, what would you say that is? Obtuse. Yeah. You're probably right. It's also scaling. I moved back too, but I'm talking about angle-wise. See how it's got that one angle that's bigger than 90? So I call it an obtuse angle. And sometimes when you have an obtuse angle, remember how you can have the height drawn outside of it? Yeah. It's still the height of it, isn't it? That's still the altitude. So it is completely possible that you wind up with altitudes that meet on the outside of a triangle. It happens. It's not a big deal. For our purposes, we probably won't work with any of those, but I just wanted to show you that it happens. The other one that happens is when you have a right triangle. When you have a right triangle, isn't this a segment drawn from a vertex that's perpendicular to a side? So what happens here with a right angle, a right triangle? Yes, sir. Yes, sir. What happens here with the right triangle, when you have the three medians meet at the right angle. Okay, the three medians meet at the vertex of the right angle. This actually takes you into a whole other thing of geometry. You actually create, what's that? We do a very small bit of that one second semester when you're talking about the altitudes and of the right triangle. It actually creates three. It creates three similar right triangles. There's a whole bunch of weird ratios that happen that actually lead you into Pythagorean theorem. We don't want to do that. I'll show you one piece of it, and that's about it. But yeah, I just wanted to show you that sometimes you'll see them both with the medians. But anyway, back to what that point's called. The point at which all three of these guys, the point at which these things all run into each other, this thing here, this is called the orthocenter. The orthocenter. The orthocenter is where the medians run into each other. Not medians, excuse me, altitudes. Like I said, it's just called the orthocenter. Other than that, it really doesn't have any fanciness. Excuse me, like some of the other ones did. They're not as crazy. They don't really have all that much else going on. I think the median one is the kind of the big kicker today. The 2/3 on the side. Let's show an example. Let's see what we can do out of this. If S is a centroid, if S is a centroid, let's see if we can figure out how much stuff we can figure out from it. Yeah, this one would be a bad one to draw out. I don't know if we'll do the algebra one today or not, but yeah, it would be a bad one. This is a pretty quick one. Maybe we'll do one example of some algebra here. Kind of running short. Excuse me. Remember, medians run into midpoints, their vertex to a midpoint. So if S is the centroid, and you know that from vertex the centroid is 4, how much is the centroid to side? 2. Okay with that? So if this part is 4, that means this part's 2. Yeah. V is a what of the triangle? V. Midpoint. Good. So if VW is 6, what's RV?
6.
I was tough. TV is the whole thing. If the whole thing is 9, TS is how much? Oh, that's a typo. VW should be 12. It says it's 6. Sorry. Thank you. I just recognized. I didn't recognize they did that before. Yeah, the whole thing should be RW. RW is 12. So if, yeah, it's just a typo. So again, back to the whole TV. TV is the entire segment, right? Which means that 2/3 and 1/3. Well, what's 2/3 of 12? I'm sorry, not 12. Excuse me, 9. Yeah, you're doing the right one. 9. 2/3 of 12 is 9, which means the other part is 6 and 3. Yeah, super easy. That's kind of all you have to worry about right now. Really is. But I think we'll wait on the algebra part of it. We'll do that stuff tomorrow. Because we're not careful with the algebra. Plus, that way you'll have a little bit less work. Just do it. Okay. Not so bad. Let me pull up the problems I had from second hour. I forgot to write them down. That was my fault.
I was like making sure I got everything.
Oops. Do those, please.